How's it going, guys? Hey, Devs here, and we're back with the second LeetCode video for today because I missed a day 2 days ago. I'm catching up and making up. Today, I did day 29 and then day 30. 30 is a pretty big day. That's like a full month of doing LeetCode. So, I found this problem. It's another binary tree problem. It's kind of easier. I have a big test tomorrow, so I wanted to make these videos pretty quick so I can get to studying. As you can see, it's 5:46, so I have about like probably 4 hours, 5 hours to study for the test before I need to go to bed. And I also have, I got to take some notes for my math class, and then I got classes all day tomorrow. I mean, I got to get up and be at class at 8, and then have a 15-minute break between classes up until I have that class at 12:30. So wish me luck. That guy's pretty rough. He gives some pretty harsh tests and pretty harsh homeworks most of the time. But I don't feel too bad about it. And that's besides the point. We're doing LeetCode today. And I did the length of last word problem. This one's a fairly easy substring problem. And then I wanted to solve it I solved it using a character array and starting at the end. And then once I found a letter, I started counting. And that one wasn't too bad. And then this one's given the root of a binary tree. Return all root to leaf paths in any order. So this one's not too bad. We just need to return a string, like a list of strings with all of the a list of strings of all the routes you can take from a root node. So the first thing, it never says that root could be null or not. It's not a case. It's not a test case that there's not a root. I mean, they won't pass you a null tree, but it's always good to test. So I created a list at first. So list string, and let me go ahead and pull up my other solution on the other. So the list string, I'll just call this a list is equal to new linked list of strings, and then be sure to call the constructor. And then the first thing I did was check if root is equal to null. I'll go ahead and return list. And I'll just return an empty list. This is a safe bet if it ever passed the null root, or if we ever go past a leaf node, which with my solution we won't. So the next thing we want to check is if root.left does not equal null. Because if it doesn't equal null, then we want to go ahead and call the list.addAll. That means it has a child, right? At least on one side. So we want to go ahead and do list.addAll, and we want to call the binary tree paths, and then pass it the root dot left. And then what we want to do is we want to just copy this and paste it, and we're going to do the same thing for the right side. So we're going to do root dot right, and then change the root dot left to root dot right. So all this does is see if it has a child on the left or right side, and if it does, it goes ahead and adds all of the routes, the routes that it has. And then the last thing we want to check is if it's a leaf node. So if root dot left equals null and root dot right equals null, that means it's a leaf node, right? And we want to go ahead and do list dot add, and we want to add the string dot value of, and this will give us a it will convert an integer into a string, and we want to pass it root dot value. And then also if it's a leaf node, if you see in the solution, like 3 is a leaf node over here, so then down here 3 is the only part of the string. And if it's a root node, like it is here, there's no arrows pointing to it. So we just want to return that one value, and we don't want to add any arrows to it. And then we just return the list, because if it's a leaf node, there's nothing under it, and we don't have to worry about that. So we can just go ahead and return that, and then it will return all the way back up, because this is a recursive function. So these will call this function recursively, so on and so forth. And then after these, this line of code just checks if it's a leaf node. We could probably do this check before. That way we don't have to check again. Well, we probably don't even need these because we return an empty list anyways. And then if you add an empty list into an empty list, it's an empty list. So once we have our two, after these two lines are called, the list will have all the subtrees under it and all the subtrees under it. And then if you were given all your subtrees, so you imagine one would be given arrow 2 and 5, and then arrow 3. And all we want to do, or it'll be given 2, arrow 5, and then it'll be given 3. All we want to do is add the arrow and then add the 1 in front of it. So we want to go ahead and loop through all of the strings held in our list. So we can do for int I is equal to 0, I is less than list dot size, and we can do I plus plus, and then all I did for this was do a string dot we can probably do an array list. I wonder if that would change, because I got a 4 millisecond runtime average, or 5 millisecond. I wonder if using an array list over a linked list will change that at all. Because we're doing a bunch of, we're removing and adding. So string dot remove. Well, we'll just do, we'll keep it linked list, and we can check that after. So we do, we create a string at first. So I'll call this string just a string, and then set that equal to list dot remove at the I, right? And then string, I went ahead and grabbed the string value is equal, we're going to do that. So string is equal to a root, or we can do the string dot value of operator again, of the root dot val. And we want to add that to the arrow, right? And then we want to add that to the string itself that we've gathered. So all this is doing is adding the arrow in front of it, and this will happen for every node unless it's a leaf node. Then it will only add the value itself and return it. And then from here we want to do list dot add I, and then the string we want to add. And then at the end, if we go ahead and return the list that we created, it should be a good solution for that one. I didn't forget any semicolons. Missing return value. Oh. Return the list. Let's submit this. See how it goes. 3 milliseconds, and we go ahead and submit this. Runs in 5 milliseconds. Now, majority of users run in 7 and 8, and then some people run it in 1 millisecond. That's insane to me. We're gonna go ahead and see what array list does, because it's just a list implemented in a different way. We can see how the times compare. So array list runs in 6 milliseconds, and the reason for that is because every time you remove a value, it shifts everything over, and every time you add a value, it adds it, and then or it shifts everything over and then adds it. So linked list is very good at adding or removing elements, versus arrays are not as much. Yes, you have to do array copying when you want to grow the array list. That's not too bad. So linked list is different, better, because we do more, once we have the size of it, like we're not adding any more to it, and then we for sure want to, we remove it and then we add it like this. But that's not too bad. If you have any questions or suggestions for these videos or this solution I implemented, go ahead and leave them down below. That's probably going to be all for this video as well. I kept both of these around like 10 minutes, so they should be very digestible. I'm about to get studying hardcore for my test. It's on operating systems. Have you ever studied deadlock, concurrency, logical memory spaces, virtual memory spaces, all that, all about physical memory, how the RAM works, how it loads processes and programs into it? That stuff is no fun. So we're learning about page faults, the page replacement algorithms, all that stuff. And those are fairly complicated and hard to wrap your mind around. And not only is it hard to wrap your mind around, it's so much material at once, so much new material that I'm not used to seeing. So most of the programming classes, like I've dealt with variables before and lists before and control structures before. Like all those are not new to me. But the way we go about it in our programming class or our operating systems class, I mean, we're not programming, we're learning about foundations and fundamentals and theory of operating systems, and like not advanced like at a master's level, of course, but we're learning about scheduling, processes, deadlock, concurrency, all that stuff, all the stuff your operating system has to deal with, which is fairly cool. But it's a lot to learn and a lot to digest. So I'm gonna spend the next few hours dealing with that. I hope y'all enjoyed this video. I hope y'all have enjoyed all the videos. Y'all stay blessed, stay healthy. Y'all keep coding, and I'll catch you on the next video. Hey Devs is out.